Okay, now we're going to look at graphing another one, and we'll do one more. It says graph each system of linear inequalities. So both of these are in slope-intercept form. So I have y is less than 2x minus 1. So we have y here. The negative 1 is the y-intercept. So we have a negative 1 here. And then we go up 2 over 1, up 2 over 1, up 2 over 1. Put several dots here so we can see what this line is doing. And there is no equal to sign. So we have a dash line, dash line. Please put arrows at the end of your lines. Less than, so I will shade to the bottom of the line. Shade, 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 shade. And then I have y is greater than 2. Please remember, everybody, this has a slope of 0. Starts at 2. Slope of 0. Horizontal line. Stop giving me y-axis. Please, just stop that. Stop doing that with your life. All right, so it is a horizontal line, and it's going to be dashed because it's not equal to. So we have a dashed line here. Put arrows at the end. It's a line, not a line segment or a dash segment. All right, so y is greater than is the greater region. What color do y'all want? I heard somebody say blue. All right, blue it is. Okay, and we shade above the line. And so our darker region over there with that would be the solution. So 3 solutions. Give me a solution would be 1, 2, 3, 1, 2, 3. So I'm going to say 3, 3. You all give me 2 more. And then give me 3 non-solutions. Yes, the work is getting less and less on my end. All right, so now you're going to come over here. Actually, I'm going to graph this one. X is less than 3. So people that have been paying attention to Mr. O'Neill know that X equal lines or X less than greater than lines are vertical lines. This is going to be a dashed line. If you need to pause the video to write down your solution, to do that. So less than 3, x is less than 3. Where are the x's less than 3? On which side? Well, they will be over here to the left. So I will get my shading out over here to the left. What color do I want? Let's pick orange. All right. Shade to the left of the line. That's less than 3. Make my shade look nice. You know what I'm saying? You know what I'm saying? All right, and then we have y is greater than x is x minus 2. So negative 2 is right here. Y is greater, go up 1 over 1, up 1 over 1, up 1 over 1. So this line looks like this. And we have another dash line. Dash lines are popular in this season. Great for dash lines. And then this is greater than, so it's above the line. Wish I would extend this a little bit more so I could show you a little bit more. All right, so we are shading above the line. What color should I pick? Somebody said gray. Well, that's weird. All right, so shade above the line. So the darker region, y'all see the color coordination, all that good stuff, is where my solution lies. And then we pick 2 order pairs, well, 3 order pairs for solutions, 3 order pairs for not that are not solutions. And then we can always check the order pairs into the inequality statement and see if they work. If they work for both, then we know it's a solution. All right, you are doing these 2 on your own. Have fun with that, especially with this one. Get the y alone. Hint, hint. Don't forget what happens when we divide by a negative. All right. And then once you're done with that, you can move on to the next slide. And then we'll talk about this. Okay, so we have y is greater than or equal to x plus 2. And then y is less than or equal to x minus 3. So let's get to graphing. So at 2, and then we go up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1. So we have a solid line. I'm going to cheat. All right, so we have a solid line. because it's equal to, and we will shade above the line because it's greater than. So we shade above the line. It's a color we haven't picked yet. Let's pick brown. Shade above the line. All right, and then we have y-intercept is -3, and then we go up 1 over 1, up 1 over 1, 1 to the right, down 1 over 1, and then we have another solid line here. I just don't know why I just automatically picked this color to be black. I just don't get that. I keep changing the color. Why? Okay, so what do we know about the lines? All right, let's shade first. So let's pick another color. We'll pick light blue. This is less than, it's going to be below the line. So what do we see? The solution is where the two shaded regions intersect. So if we look at the solution, we see that the solution, there is no solution. You know why? Because the shaded regions do not intersect. And we know that when we have no solution with equations, we know that the slopes are the same. The slope here is 1. The slope here is 1. But it does not mean that because the slopes are the same, that doesn't mean in an inequality that the solutions will be no solution. It'll be no solution if one is going up, shading up, and one is going down, which means they will never intersect because these lines never touch. So this is what no solution looks like. It looks like one has greater than and one has less than. But we'll see in a second that all of these will not be no solution. So look at the next one. So M is 1, B is 3, so go to 3. Put a dot here, up 1 over 1. We like slope to be 1. I guess so. So notice offhand, I already know that this is going to be, I'm just going to do my best. That's all I can do. That's all you can ask for. Do your best. We always automatically see that this is going to be parallel lines. But let's see what the solution is going to be. So this says y is less than, so I'm shading below the line. Right, this already looks a little different. Let's pick yellow again. So I'm shading below the line, right? Everything below the line and on the line will be a solution to this linear inequality. But when I look at y is -1, it's already in the region of the solution. So I can automatically conclude that this is not going to be a no solution problem, even though the lines are parallel. Up 1 over 1, up 1 over 1. Somebody's going to do his best. And where would I shade here? Well, I will shade above the line because it says y is greater than or equal to. Oh, I just noticed something. I made a mistake. There should be a dash line. Dash, 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 dash. Maybe you caught it already, and you probably want to walk up to me, somebody like Rosie, and be like, oh, you made a mistake. Okay, so this is going to be greater than, so it's above the line. So look at where my solution is. My solution is in between the parallel lines. I would extend that line. So here, the solution is in here. So any 3 points inside of these two parallel lines will be the solution. So write down 3 solutions, write down 3 non-solutions. And lastly, 1. I guess we can keep it red. Down 1 to the right 3. Down 1 to the right 3. Up 1. And then this is a solid line. Use my line tool because I got to stretch a long way. Look at that. It's only a quarter beforehand, I should say. All right, so, and then this is greater than. So y is going to be greater. So I will shade greater, greater, greater above the line. Like that. And then when I graph the next line, We start at -2, go down 1 over 3. We know the lines are parallel. If these were equations, we would say, hey, no solution. But since we have to actually shade them, we can't say, hey, no solution. And I'll be like, hey, you're wrong. A little better dashes than that. And this says y is greater than, so it's going to be dash, and then I shade where? Above the line. Watch out now. I don't like that color. It doesn't really show that well. No. It's going to jack up our lives. I don't really like this either, but I'm tired of picking. So where's the solution? The solution is now here. So any point on the line or in this double shaded region. So what you're going to do, you're going to finish here. Please let it be known this is a 3. This one, that one, and you're done because we're not going to do group work. All right, have fun, people. Math is great. I almost forgot. What is wrong with me? It's been great. We out. See you next time.